My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 260, page 261, the very first problem on the page, number 11. Let's take a look at it. We are given a parallelogram ABCD. Let's reproduce it here. That's about it. We are told that this distance is 2, this is 4, this is 90 degrees we are told, A, B, C and D, and this is 12. Is that it? And then they give you a dotted line here. Oh, blasted. Wow. So that's what it is. They ask us very first thing, area of ABCD, area of the parallelogram ABCD. Area of the parallelogram ABCD. Well, let's take a look at it. Ordinarily, when we're talking about the area of a triangle, for example, area of the triangle ABD would have been 1/2 base times height. The triangle ABD would have been 1/2 base times height, which is 1/2 times base, which is 12. The question is, what is the height of this triangle ABD? The height of the triangle means exactly what it says. To find out the height of any triangle, we take the highest point, the highest possible point we can find on the triangle, and we ask ourselves, how high is that point from the base? We draw a perpendicular and we ask ourselves, how high is that point from the base? Well, that height that you see there, that we just drew here, we are told how high that is. On the other end of the picture, we are told that it is 4. That height is this height. Therefore, it's 1/2 base times height. That would have been the area of the triangle ABD. Then the next thing we have to realize is that this triangle ABD is same as the triangle BDC. ABD is same as the triangle BCD. Triangle BCD. The exact same triangle, because it's a parallelogram which has been cut in half. So if the area of the ABD is 1/2 base times height, then area of the whole thing is got to be simply area of the ABD is got to be simply 12 times 4, because this is 1/2 base times height, and this is 1/2 base times height. So it's just 12 times 4, which is 48. That's all. That's all there is. If you want, I can show you another perspective as to how to look at it. There is another perspective to the whole thing, which is this part right here. I'm going to redraw it and watch what happens. And this is of course is true for any parallelogram. What you do is, this triangle that you see there, the exact same triangle exists here. The exact same triangle exists here. Or rather, that's not what I meant to do. This triangle that I plotted here is the exact same triangle as this guy right here. So essentially what we're doing is, we're chopping this triangle off. We're chopping the triangle AB, this triangle that I just plotted a little while ago. I don't want to do it here. This triangle that is A, B, and if you were to draw a perpendicular, and if you were to give it a name here, let's call it E here. So if you were to chop off this triangle and pick it up and transport it and put it here, put it here, what will end up is this triangle will disappear because we're chopping it off, and we'll end up with a regular rectangle, a 12 by 4 rectangle. And that's all it is, which is why it's just 12 by 4. So that was part A. Part B. The perimeter of the thing. Alright. Perimeter of A, B, C, D. So let's erase all of this part that we no longer need here. We don't need any of this. And this thing we told is 12. In order to find the perimeter, we already know this side. This side we know is 12. We are told that this side is 12. And of course, B to C is 12. We have to find the length of this guy. Length of this guy. Which is very easy, very straightforward. We are told, because we are told that this is a right angle. So let's look at triangle CD, and I'm going to call this vertex, I'm going to give it a name, let's call it E. In triangle CDE, let's call this hypotenuse X. So in triangle CDE, your X squared, which is your hypotenuse square right here, equals the square of this guy and the square of that guy. 2 squared plus 4 squared, very straightforward. 2 squared is 4, 4 squared is 16, 16 plus 4 is 20, so it's 20. Therefore, X is square root of 20. So that's your X there, which is same as this guy right here. So the perimeter is simply 2 times this side, which is 12, because we got 12 here and 12 there. 2 times 12 plus 2 times X, which is 2 times square root of 20. That's your answer, that's it. You could leave it like this, or we could do something with it. You want to do something with it, or do you want to leave it like this? Let's do something with it, and let's present it in a little bit more elegant manner. The square root of 20 can be written as 4 times square root of 5. The square root of 20 can be written as square root of 4 times 5. The square root of 4 we know is 2, so this is simply 2 times square root of 5. 2 times square root of 5, I'm going to put that here, so it's 2 times 12 plus 2 times square root of 5. And I'm going to take out the 2 common. This is 2 and this is divisible by 2. Let's take out the 2 common. If you take out the 2 commons from here and here, 2 times 2 becomes 4, and you end up with 12 divided by 2 is 6, and you will end up with, this is, I'm going to erase this part, this is too annoying. That's it, that's your final answer. That is the perimeter of the guy. Part C asks us for the length of the diagonals BD. Alright. Length of the diagonal BD. To find the diagonal BD, right here, this guy BD, here's what we're going to do. From D to E is 2. From D to E is 2, which is same as A to, we have A, B, C, D, E, let's call it F. A to F is same as D to E, which is 2. Okay, stay with me in the story. So instead of 12, what it is A to F is 2, and F to D is 8. Now we are done. And B to F we know is 4. B to F is same as C to E, which we are told is 4. So this is 4. So now we look at this, and this is of course is the right angle because we are dropping a perpendicular. So to find the diagonal, we look at triangle BFD. In the triangle BFD, which is what it looks like, BFD looks like this. Here is your B, here is your F, and here is your D, and this, let's call this Y because we already used the X, B to F. B to F is 4. F to D we said is 8. So that's it. Another straightforward right angle triangle, and we just solve for y. So in this case the y squared is going to be 4 squared plus 8 squared. 4 squared is 16. 8 squared is 64. 64 plus 16, 6 plus 4 is 10, so that gives us 0. Carry 1. 1 plus 6 is 7, plus 1 is 8. Which is 80, which I'm going to write that as 4 times 20. Or better yet, we can write that as 16 times 5, which can be written as 16 times 5, and therefore y equals the square root of 16 times 5. 16 times 5, and of course we know the square root of 16 is 4, so this can be written as 4 square root of 5. That's it, that's your y. Which is not what I have in my notes. Bloody hell. Which is okay. I'm not gonna... You're watching it obviously still, and this is not the first time you've seen me make a boo-boo. So we're gonna go back and find our boo-boo, what happened. Oh, jeez. I do not know how to subtract things, do I? This guy was 12. From A to D, from A to D, listen carefully please, A to D, we were told was 12 in the original picture. A to D is 12, and A to F is 2, which means that F to D is 10. F to D is 10. You see this guy here? I'm going to put it on the top. This is 10, and this is 2. If only I knew how to subtract 2 from 12. 12 minus 2 is not 8, it is 10. It is all wrong. This 8 should have been 10. It's a good thing I checked in my work here. This should have been 10 squared. This should have been 100. 100 plus 16 is 116. Y squared is 116. Y squared is 116. 116 of course can be divided by 4 obviously, because the last two digits are divisible by 4. There are 25 4s in 100, and there are 4 4s in 16. In other words 116 divided by 4. How many 4s in a 1? There are 0 4s in a 1. That 1 goes and joins this guy, becomes 11. How many 4s in 11? 11 has 3 4s. 11 has 2 4s rather. 2 4s. The remaining 3 goes. The remaining 3 from the 11 goes and joins this guy, gets 36. How many 4s in a 36? 36 has 9 4s. So this becomes 4 times 29. 4 times 29. And therefore y equals the square root of 4 times 29. And of course square root of 4 is 2. So this finally becomes 2 times the square root of 9. Well, that's much better. That's what I have. Okay. What I was trying to explain to you, the way I was figuring it out, how many 4s, the way I was trying to figure out how many 4s in 116 is this. Listen carefully. I know that 100 is made up of 25 4s, because 25 times 4 is 100 obviously. 4 quarters make $1. So 100 is made up of 25 4s. And I also know the 16 is made up of 4 4s. 4 4s are 16. So 25 4s plus 4 4s will give us 29 4s, which is what I was trying to make you understand. But I did it out here this way, just so you can understand my logic. That's what I was trying to figure out. So it's 2 times root 29, which is the length of B to D, the diagonal B to D. That's all. We are done with this problem. I will see you tomorrow. Sorry about the boo-boo. I will see you tomorrow where we'll do the next problem, problem number 12. which has to do with circles. Problem number 12. Alright? Bye now.